Okay, now that we know what logs are, let's see if we can actually answer some logs, find some logs. When you see log base 2 of 8, this is what you want to translate that as in your head. You want to say, okay, what exponent would I put on the 2? What exponent would I put on the 2 to get an 8? You don't want to think about division here. It's, in other words, 2 raised to some power equals 8. Well, 2 to the third power, 2 times 2 times 2 gives me 8, so the answer here is 3. Likewise, if I have log base 5 of 25, I'm asking what exponent do I put on this 5 so that my answer is 25, right? So 5 raised to some power equals 25. 5 times itself, how many times is 25? 2, so the answer is 2. Log base 4 of 64, 4 raised to what power is 64? Well, 4 times 4 is 16, times 4 again is going to be 64. So the answer is a 3 because that's the exponent I would need. That's the number of times I would multiply the base with itself to get this answer. Now here I've got a few more unusual ones. What if I have log base 7 of 1? Okay, so let's translate that. The exponential equation would be 7 raised to some power is equal to 1. Well, the only way to raise something to a power and get 1 is if you raise it to the 0 power. So the answer here is 0. Log base 3 of 1/9. So 3 is my base. I'm raising it to some power, and it equals 1/9. So I've gone from a whole number to a fraction, which means I've got to put the 3 in the denominator. I'm going to need a negative exponent. And to get from 3 to 9, you'd have to square the 3. 3 times 3. And so the answer would be -2. And then here's another kind of weird one. We have to remember exponent rules. Log base 6 of the square root of 6. Well, that's equivalent to saying 6 raised to some power is the square root of 6. But remember that roots are the same as fraction exponents where the denominator of the fraction matches the kind of root. So the square root is equivalent to the 1/2 exponent. Okay, my answer then would be 1/2 over here. The answers for these log problems are the exponent that you need. I'm going to take a look at a couple special bases. The first is base e, and instead of writing log base e of x, because it's such a useful one in applications, we shorten it up, we give it its own notation, and that's an ln, not a 1n, ln of x. That's called the natural log. On your calculator, you have a capital L, capital N. That's the same thing. Sometimes people write it with the capitals. And you notice, I want you to notice this, right above the ln in really small letters there is an e to the x because those two go together. So if I have ln of e, and I'm asked to answer what that is, I recognize that because it's ln, I know the base is an e. So I'm asking e raised to what power gives me e? Or this equation right here. Well, it'd have to be the first power, right? Something raised to the first power is just itself. What about ln of the cube root of e? So again, because it's ln, I know automatically my base is e. I raise it to what power to get the cube root? Well, again, roots are fraction exponents, so it would be 1/3. If it's ln of 5, I'm asking e, because it's ln, e raised to what power is 5? Well, e was at 2.718 number. I don't know what the answer would be. So on the ones that you can't do just by looking at them, you want to go ahead and grab your calculator, do ln of whatever it is, and put it in, and you get your answer, which we're going to have to round. The other special case is base 10. And this, instead of writing log base 10 of x, we would write as log x. So when it's log with no base written there, you get to assume it's 10, and that's referred to as the common log. Now this shows up in the Richter scale for measuring earthquake magnitudes, and also in decibels and in other examples. But those are two that we'll probably look at in our applications. If I have log base log of 1/100th, I'm asking base 10 raised to what power is going to give me 1/100th? Well, because I went from a whole number to this fraction, I'm going to need a negative exponent. To get from 10 to 100, it would have to be 10 times 10, so -2. Now you do have this on your calculator as well. Right above that ln is the log, and right above that in little yellow is 10 to the x. So the 10 and the plain log go together, the e and the ln go together. That's kind of a built-in cheat sheet for you. And we could use our calculator to do this one too. So log of 1/100th. And yep, confirms the answer's 2. What about this? Log of 1. Again, there's no base, so I know it's 10. 10 raised to what power is a 1? Remember, to get a 1, you'd have to raise it to 0.